guys, let's pause for a moment of science today and talk about data collection. We are going to learn today about the two main ways that scientists collect data. They are called qualitative and quantitative data. So I'm going to write those on the board. So qualitative data and quantitative data. Let me make that bigger. All right, so qualitative and quantitative. I'm going to pull you closer so you can see. Now, the reason why I made the L in qualitative so large is because it gives me a hint that qualitative data is basically what an object looks like. So when we are collecting data, one of the main things we will do is make an observation with our eyes and kind of take in what's going on. So we observe. In qualitative data, you observe. You use your 5 senses to collect that data. S-E-N-S-E-S? Yes. And so that would be your eyes, ears, nose, mouth, and your hands, which would be touch. So eyes, ears, nose, mouth, and hands. So basically you're looking, you are listening, you smelling, but not always. Be careful with science. But sometimes you will make an observation by smelling, tasting, again, not always, and touching. Use your hands to touch it. Now let's talk about quantitative. All right, quantitative data, the N is really large because that gives me a hint that quantitative data has some kind of number. There's a number involved, and that's because it is a measurement. And when you measure something, you always include a unit. And when you measure something, you have to have a type of tool, something that will give you the answer. So that's qualitative and quantitative. So for example, if I am asking someone their age, okay? So if I said, how old are you? And you told me that you were 12, well, first of all, that's a number. So according to quantitative data, it's going to have a number, so there's a check, and then it's going to have a unit. So if I ask you your age and you tell me 12, the unit is years. All right, so there's check on years. Now what's the tool for age? Well, that would be a calendar. A calendar is the tool that we use to measure someone's age. So think about when we say tool, it's not always hammer and nail. Sometimes it could be a clock, it could be a ruler, a scale that would measure weight. Those are all different tools that would give us a number, and then of course you always have a unit that matches that number. Really? Okay. So for today's experiment, we are going to make a mini waffle. I have this really cute, whoops, upside down. I have this really cute mini waffle maker. And so our goal today is to make a waffle, but along the way, we're going to collect qualitative and quantitative data. So here we go. We're gonna start with a waffle recipe. We have 3 tablespoons of pancake waffle mix, 2 tablespoons of water, and 1 tablespoon of chocolate chips because chocolate. So the first thing we're going to do is we are going to collect qualitative data. So if we look at the mix, there are a lot of things we could say. It has a texture of a powder. It looks soft. It is a very light yellow color. Those are some different things. We could smell it. I don't even smell anything. I'm sure it has a smell, but my nose is not picking up anything that I could, actually put a word to it. Then we can go to what, and there are more things we can say about this, but just as a review, the water, it is clear, it is jiggly or wiggly, it moves, it flows. Those are all ways to describe water. It is wet. If we smell it, it has no smell. It's odorless. We could taste it if we wanted to. And then the chocolate chips, we could smell it. Yep, smells like chocolate. We could talk about how they are solids, they are small, they look smooth, they are brown, they are milk chocolate. Instead of the semi-sweet, the bag I opened is milk chocolate, so it's a little bit lighter brown than a dark chocolate. And now we need quantitative data. Well, we kind of already did that when we talked about the recipe. Our quantitative data is we had 3 tablespoons of mix, 2 tablespoons of water, 1 tablespoon of milk chocolate chips. We could collect more data if we put these on the scale and weighed them or took the mass of them. We could use a thermometer to measure the temperature of them, but we'll save some of that data collection a little bit later on in the experiment. Now what we want to do is we want to combine our ingredients. We want to be able to collect data on the next step. So we collected data on the ingredients. Now let's mix them together and collect data as a batter. So there's our mix, our water, and our chocolate chips. All right, and we'll mix this up. Let's see if I can just show you that. My fancy spoon. All right, now let's collect some qualitative data. If we look at this, I would now, it looks like a darker yellow. I see bubbles. It looks lumpy. It looks thick. It smells like baby formula, like formula for babies. I don't know, it has like a weird, I don't know, kind of chalky smell to it. I could taste it. Tastes like flour. I don't know. I don't know. And now let's take some quantitative data of it. Well, the foam cup adds a little bit of weight, but just for an example, we're not going to zero out the scale for the foam cup. So I have a scale. The scale is set to kilograms, and I'm going to weigh this. And it's actually going to give me my weight in ounces. It is 65 ounces. So in quantitative data, the number is 65, the unit is ounces, and the tool is the scale. All right, now let's move on to the next step. We're going to plug in our waffle maker. Going to transfer the energy from the cord to the waffle maker, and it's going to begin heating up. When the green light comes on, that actually means that it's ready to cook, but we may go ahead and put it in there a little early just for the sake of the video. Let me give a little squirt of nonstick spray. Let me see where I can put that and you can see it better. There we go. And now we can take some data as we are in the actual cooking process. So pour your batter in. You need to spread that out a little bit. So we're making smoffles, which means small waffles. Ha ha ha. If I took some qualitative data, I could talk about maybe the shape of it, the texture of it. I can tell that the texture from the heat is already starting to change just a little bit. It looks like it's really thickening up. I am seeing some more bubbles. I am actually hearing, sizzle, almost like a sizzle. That's some of my qualitative data. If I wanted to take some quantitative data at this step, I could take a thermometer. Let me put it there, Fahrenheit, and I could measure the temperature, which the longer I leave it here, the more the temperature is going to change, correct? Ooh, look how that texture is changing on the other side. Already over 150 degrees. Ooh, almost 160. All right, so for the sake of video, I'm going to stop it right here because it's just going to keep climbing and climbing for a little while. I want to make this an insulator, so I'm going to close the lid. Ooh. What am I observing? Don't say smoke. What is that? That's steam. So if this is steam, that means it's losing some water. It's losing some water. So if I weigh my waffle, is it going to weigh more or less than it did when I put it in? It's going to weigh less because it's losing all of this water. Let me just take a peek. Boy, that looks good. Let me get a spatula and a tray. Oh, got a little bit of cake mix on there, but that's okay. Let me check the edges, kind of loosen it up. And I can take out my small waffle. Whoop! No chocolate left behind. No chocolate left behind. Get. Don't look. Don't do this at home. Just watch me. Oh, so good though. All right. I'm gonna unplug that to stop the flow of heat. Let that cool off. Let it lose its energy so that it cools back down. And I have a waffle. I need to take some qualitative data on the waffle. I can say that it's now a solid. I can say it's round. It is definitely thick and more stiff and crunchy in places. The chocolate chips have melted a little bit. It looks like most of the chocolate is near the center. There's not very much chocolate around the edges. It smells, oh, sorry, that was my necklace. It smells good, actually. It smells kind of like bread. Now let's take a taste. It's good. Definitely a different taste than when it was just batter. When it was batter, it had this weird chalky, I don't know. It was not flavorful at all. And it's kind of interesting. Sorry, I'm chewing. Let me chew this up. Hang on. All right, so it's fascinating to me how not just the color changes, the texture changes, the state of matter changes, the smell changes, and the taste changes, and all we did was add heat. That is crazy. If we, oh, you know what? I should have weighed it before I ate it. Oh, man. All right. Let me get some quantitative data. Sorry, I got hungry. If you know me. Well, you know what would be awesome? A new set of batteries. Let's try this one. And of course, the tray is going to add just a little bit of weight to it, but I wish I hadn't eaten some. Yeah, I can't weigh it and compare it to the batter because it's in two different containers. I'd have to put it back in here. Ugh. Well, that's not going to be pleasant. Let me just see if I can do that. I'll take one for the team. Just put it in there. There we go. And now I'm going to weigh it. Give me some quantitative data. It's 45. Now, of course, I took a little nibble, so I probably took about 10 off of it. But if you remember, when it was batter, it was 67. So my guess is it lost about, I would guess it lost about 10 ounces in water vapor when, well, technically steam, which is a liquid. Water vapor is a gas. But when it lost about 10 ounces in steam. Okay, I just watched the video back and I need a major correction. When I was weighing the batter, I should have been wearing my glasses because instead of 65 ounces, it was 6.5 ounces. Instead of losing 10 ounces, it was 1.0 ounces. And so our final results were actually 4.5 ounces, not 45 ounces. Getting old stinks.